All right, stats, welcome to your exam number 2 review. Got all the reviews, all the answers here very quickly. I thank our sponsors, Cliff Bar, Tazo Tea, and an in-town sponsor, Chinatown. Yes, thank you to all three. Guys, the answers for number 1 are as follows. Remember, the strongest R values are the ones that have the absolute value closest to 1. For number 2, here are the answers. Remember, the slope, the sign of the slope is the sign of the R value correlation coefficient, okay? Again, going through these answers very quickly. We should have talked about almost all of these in class. Yes, I know, is this one B or is that one C? That one's a little tricky there. I'll make it a little bit more obvious on your test. The answer is definitely not though I. Never choose I. There's really only 2 that are in there that have a chance to be picking that aren't. Anyway, interpret the slope. For every day missed, your grade goes down by 1.34 points. That means when you miss 0 classes, the y-intercept 91.24% is the highest you can get. Highest because days missed, that's negative, so your grade goes lower the more you miss. Anyway, that's too low. That's too low of a score. Predict the grade for someone who misses 8 days. Just plug 8 in for x. That's a score. Find the residual, y minus y hat, folks, for a student who earned a 95, missed 12 days. Plug 12 in for x. They should have gotten a 75.16. They did get a 95. 95 minus that, 1984. Find the residual for a student that missed 1 day but earned a 72. Plug 1 in there. They should have gotten 89.9. 72 minus 89.9. Residuals can be negative. That means you underperformed in most cases. According to this model, if a student wants to earn at least an 80, they should miss no more than blank days. Put 80 in for y hats and solve for x. 8.39, put that down to 8. According to this model, if a student wants to earn at least a 70, they should miss no more than. Solve that. We're going to round that down to 15. You're going to go down to 15 there. This is your first official review. Here's the answer for 5. 3.04 is the slope. For every year a person ages, their cholesterol goes up by about 3.04. Y-intercept means a person of age 0, a newborn, already has cholesterol of 134, or 134 is the highest or lowest cholesterol you can have. That's just not going to be true. Both those, so again, Y-intercept on its own, usually not good. Calculate the residual for a 25-year-old with a cholesterol of 164. 25 is what you plug in for x. You get a y hat of 210. 164 minus 210.61. You want to underperform here. You want a lower cholesterol. Calculate the residual for a 40-year-old with a cholesterol of 255. Plug 40 in. Get a y hat of 256.21. Subtract the 2. Again, you want to have a negative residual here. That's good. Predict the cholesterol value for a 33-year-old. Just plug 33 in for x. According to this model, a patient with a cholesterol of 200 might be predicted to be what age? Just plug 200 in for y hat. 21.5. Okay. That's your data here for 7. We're going out of order, so actually let's do 6 first. All right, you have your x and y. Just simply put x in list 1, y in list 2. There is your least squares regression line. Interpret the slope. For every mile you run, your 5K goes down, time goes down by 0.03 minutes. The y-intercept means if you run 0 miles, expect an 18.26 minute 5 or 0.26 minute 5K. No way. That's bad. R negative, again, more you run, the lower your time gets. Bell's gonna ring here. That's moderate. That's a moderate, not fantastic, moderate. Plug 55 in for x, see what you get for y hat. Find the residual, plug 65 in for x. They should have run a 16.31 5K. They did 16.85. Here you want a negative residual, so they didn't really overperform. They ran more time. They ran slower than predicted. Okay, is this, I believe this is number 8. Let's look at number 8, folks. The following data displays the number of home runs hit by a team and the number of runs they scored in a given year. All right, all that right there. Find the least squares, regression, slope, and interpret the slope and the y-intercepts. All right, that's it. Basically, for every home run they hit, 1.15 runs are added to their run total. A team that hits 0 home runs, will score 486, or 0 homers will score 486 runs. That's a pretty strong R. Calculates the residual for 175 home runs and 712 runs scored. Plug 175 in for X. That's Y hat. Y minus Y hat. They overperformed. Predict the number of runs scored for a season with 180 homers. It should be that. Plug 180 in for X. And then which season would have the bigger residual? Plug 170 in for X. They should have done that. In real life, they did 644. 644 minus that is a negative, almost 38. Plug 182 in for X. Subtract from, do 711 minus that. Even though that is a larger number, it's all about the bigger residual has the biggest absolute value. So actually this guy is off the most. So that has the biggest residual. Okay, I believe, guys, on 7, the data was here. Days missed was an X, GPA was an X, and ACT was a Y. So, getting there eventually. This makes for great. This is unbelievable. What great video we have here. All right, here we are. So if I put days missed in X1, or as X1 in list 2, and GPA is X2 in list 3, and ACT in list 1. Again, you can do whatever you want, however you want. Days missed in ACT form linear regression model is right there. GPA and ACT linear regression model is right there. Days missed in ACT have the following R and R squared values. GPA and ACT have the following R and R squared values. So which one is stronger? The one that is closest to the absolute value, the one that has the absolute value closest to 1, which is 0.83. If a student missed 6 days and had a 3.1 GPA and earned a 26 on the ACT, calculate the residuals for each model. All right, so in the days missed model, plug 6 in. That's their Y hats. They actually got a 26, Y minus Y hat, 1.11. They did 1.11 points better. 3.41 GPA, plug that in for X. They should have gotten a 25.38. They did get a 26. Subtract the 2. They overperformed by 0.62. They performed better in that model. Just really know how to do A through D on those. Guys, again, here's the answers for what you did today in class, what you did Wednesday in class for the first one. All right, which one's stronger? The second model's stronger. Why? It's because you're getting rid of those older kids that were shorter than what they should have been really at 16 and 17. All right, you guys plugged all that data in. That's your 2017 model. It's your 1998 model. That was the stronger, and this adds more runs. The slope is bigger. Okay. And my page 3 did not copy through, but I think we did a good job on page 3, and I don't think page 3 is anywhere to be found. Oh, I lied. Page 3, again, incredible video here. Page 3, here are the answers. Again, negative slope means negative correlation coefficients. Pause this whenever you need to. The slope is 18.238. That means for every person added to the households, you need $18,238,000 to maintain middle class status. The y-intercept means if you have 0 people in your household, you need $15,000. You do not. That doesn't make sense. How much money do a family of 4 need to make to be solidly middle class? Plug 4 in for X. You get that. Find the residual for a family of 5 who has an income of $130,000. So put the family 5 in, not 134, 104.75 thousand. They should make 106.229. They actually make that. That minus that is they have a negative residual. They need to make about $1,500 extra dollars. Now, if you make 130, how many people in the house could you take care of? Put a 130 in for Y hats and then solve for X. 6.3 means you can relatively comfortably handle 6. All right, and then lastly, what you're doing on Thursday in class, given the following 3 correlation coefficients, state the 3 strongest and 3 weakest values. Strongest, closest to the absolute value is closest to 1. Weakest, the absolute value is closest to 0. All right, guys, on this one, you take the square root. Now, it's either plus or minus. So the first one, plus or minus 0.66, plus or minus 0.58. Well, folks, the strongest model has the R, the absolute value of the R closest to 1. It's still, the biggest R squared is going to give you the strongest model. So it's still going to be that one, no matter if it's a negative 0.66 and that's a positive 0.58. All right, so that's a good question there. And number 3, BCI, GHF. It can definitely not be E. And right here, folks, interpret the slope. For every 1 point increase in GPA, the ACT will rise by that many points. If you have a GPA of 0, y-intercept, you should get a 10.46. You're not going to have a GPA of 0. It's just not going to happen. Plug those following GPAs in for X, and you get your y-hats. Again, pause this at any time. You need the answers a tad slower. Find the residual of someone with a 3.47 GPA. Plug that in right there. They should have gotten a 28.99. In real life, they got a 28, so they're pretty much off by a point. Find the residual for a student with a 3.92 GPA. Plug that in. They should have gotten a 31.39. Real life, they got a 25, so they underperformed by 6.39 points. And a few more pages here. 2017 data on number of saves a team earned and the number of games they won. Saves is X, so do what it says here. This is your linear regression equation. R squared, comment on the strength. That's moderate, it's not the best. So with that equation, plug 39 in for X. They should have won 80.69 games. They won 78, so subtract. They underperformed by about 2.7 games. Cleveland had very few saves, really, so they should have had a losing record, and they actually overperformed big time, so they just didn't get a lot of saves. Right. Again, this is what you do Thursday in class. Number 6, 1997 NL AL home run and run scores data. List 1, list 2. You can clear lists and again put this in list 1, list 2, or you can do list 1, list 2, list 3, list 4. Just know that runs is your Y. The NL has an R of that, R squared of that. AL has an R of that, R squared of that. NL had the highest R value. NL had a linear regression model of this. AL had a linear regression model of that. What's the highest slope? What's the largest slope? So it should be, yep, largest slope. 1.74. So that means when an NL team hit runs, when it hit a home run, they got 1.7 runs added to their run production totals, whereas the AL only got 1.47. 200 home runs, so in the NL, that would, of course, plug that in for X in both equations. In the NL, you get just over 825. In the AL, you would get 831. All right, so even though they hit the same amount, it's just that, you know, the y-intercept here is larger. So even though, you know, in this last one, you might be like, wait, you just told me the NL accounts for more. Each home run does. The AL is getting more run production from elsewhere. Right, from elsewhere. So eventually this will catch up to where it overtakes it. It's going to take a lot of home runs. All right. And that's it, folks. Great. That is your test review video. Your test is now Friday, October 13th. All right, folks. This is Yak Math Videos signing out.